talking about what is radioactivity. Radioactivity is basically a spontaneous disintegration disintegration of nuclei of an atom due to instability. Nuclei of an atom due to instability, right? Unstable nuclei gain stability. Unstable nuclei gain stability by emitting alpha, beta and gamma. Oh, remember that alpha and beta are the particles, while gamma is the electromagnetic radiation. This is electromagnetic radiations, right? Okay, so this all the experiment, not radioactivity is not affected, isn't it? Isn't affected by temperature, pressure, means all the physical quantity, all the physical conditions, right? Physical conditions. And this is nuclear reaction, which usually nuclear reaction which occur between two nucleus, nuclear reaction. Okay, and the unit to measure the radioactivity is becquerel, which was named after who actually discovered the radioactivity. Okay, so radioactivity is a nuclear reaction or a phenomena entirely different of chemical reaction, and the rate of emission depend upon alpha, beta, gamma, depend on the concentration of a nuclei. If size nuclei is high, which means the reaction high. Okay, what he did, he performed an experiment. Before that, I want to tell you one thing, that among 1500 nuclei, only 260 nuclei are stable. Okay, so what did Henry Becquerel performed an experiment? He took an uranium atom, and then he placed a silver foil. Remember that we can assume that the silver foil was also wrapped above this uranium atom, and here it has black paper. Okay, our drawing is a bit messy, but that's fine. This is photographic plate. What it did is he wrapped it and left it for some time, and after a while, he noticed that some black spots were found on the plate, through which he assumed that some sort of radiations are being emitted by the radioactive substance, which he named as Becquerel rays. Later on, it was named as alpha, beta, and gamma rays, right? So, for all the atomic number greater than equal to 20, they have stable nuclei. Which means the ratio of neutron to proton is 1. For example, carbon 6 and 12, 6 proton and 6 neutron. Nitrogen 6 proton and 7 proton and 7 neutron. So it's stable, right? So for example, this is an atom. This is neutron. Or this is proton and proton, right? So the force that exists between proton is electrostatic force. Now I'm explaining that why these atoms are stable, right? Electrostatic force. And the force between neutron and neutron, this is a nuclear force. Nuclear force is a stable force, is much more stronger than the electrostatic force, and is not dependent on the charge. However, the attraction force at small distance okay, so this is neutron, proton. The exists between these two is the electrostatic force. While the force between neutron and proton is the electrostatic, not electrostatic force, but the nuclear force. And when the electrostatic force, we can consider here one thing, that electrostatic force we consider for sense of repulsion, and the nuclear force, however nuclear force can be attractive, repulsive as well, but here we're considering as positive or attractive force, right? When they both are equal, the atom is stable, nuclear force. However, when the force is more than of other, then nucleus become unstable or gain some or shape changes, it changed into some other shape, right? So for example, when this is clear that why these atoms are stable, just because the number of nuclear force balanced by electrostatic force, the no net force on the both is zero. The net force is almost zero, so that's why they're the stable atoms, right? And when we talk about the atoms greater than less than where the atomic number is greater than 20, for example cobalt, Ag, Au, we know that the number of neutrons here is high and they have a ratio of neutron to proton is 1. 1 greater than neutron proton ratio is greater than 1 and less than equal to 1.6. The number of neutron more than the number of proton, but stable because of nuclear forces, and nuclear force is a very strong force, and usually they stable themselves by emitting the neutron, which is beta minus, that is electron, stable itself by emitting such particles, beta particles, right? So here also nuclear force balance the electrostatic, and that's why they have a stable nuclei. But bismuth is the last element which has bismuth is last, not last, is has atomic number 83. Wait, let me confirm it. Yeah, it has a atomic number 83 and it's the last stable nuclei. Okay, is it the last stable nuclei? After that we have atomic number less than no, atomic number greater than 83. They all are radioactive substance. So number of neutron is needed to balance for the repulsion in between protons. Okay, less proton to neutron stable itself by releasing beta plus, which is positron, and alpha. Okay, alpha. For example, the number of neutron to proton is less. They make themselves stable by breathing beta plus, which is positron, and alpha. Okay, so this is the introduction basic.